Hey everyone, today we'll be talking about finding the axis of symmetry given quadratic functions in standard form. Here's the focused learning target for today. Given a quadratic function in standard form, I will be able to find the axis of symmetry. So what is the axis of symmetry? Well, the axis of symmetry is basically a straight line that splits a shape in half. Kind of like folding a paper in half. So let's say we have a parabola, so quadratic function, and we draw a line down the middle. This is our axis of symmetry, the AOS. Notice that each side becomes a mirror image, kind of like the reflections we talked about last year. The axis of symmetry splits your shape in half. Let me highlight some of the key words here. Axis of symmetry, half, mirror. Here are some general examples of axes of symmetry. Notice how each axis of symmetry splits the shape in half. It's a vertical line splitting the shape in half. Notice here, this axis of symmetry, so the AOS is a vertical line. Remember from our earlier topic where we talked about vertical lines, they have the form x equals a constant. Again, the AOS will have the form x equals something, where something is a constant. But how do we find that? We actually have a formula to find the axis of symmetry. Remember how in the previous topic we labeled A, B, and C of quadratic functions in standard form? Well, we're actually going to use some of those parameters. So the axis of symmetry of a quadratic function is, since it's a vertical line, we have x equals negative b over 2a. Or we can also write the negative up here, so negative b over 2a. Notice we need the a and b values from the quadratic functions. For example 1, we will find the axis of symmetry of f of x equals 3x squared plus 6x plus 5. Notice here it's written in standard form. So let's first label A, B, and C. We see that A equals 3, B equals 6, and C equals 5. Let me write this down here. Again, A equals 3, B equals 6, and C equals 5. We're going to use this to find the axis of symmetry. So the formula to find the AOS is x equals negative b over 2a. So negative b divided by 2a. What's b? B equals 6, so I'm going to replace the b with a 6. So for the top, or the numerator, I have negative 6. And since a equals 3, instead of 2a, I have 2 times 3. Again, I'm just replacing the letters a and b with its actual numbers. So I replaced the b with the 6 and the a with the 3. Next, I multiply the denominator. So I still have negative 6 over 2 times 3 is positive 6. I now have negative 6 divided by 6, which equals negative 1. So my axis of symmetry for this quadratic function is x equals negative 1. I'm simply replacing or substituting the a and b values with its actual numbers. What would this look like on a graph? Notice here we have the quadratic function, the parabola, and then its axis of symmetry is at x equals negative 1. Let's look at a similar example. Here we have f of x equals 4x squared plus 16x minus 1. Again, it's written in standard form, so let's label A, B, and C. A equals 4 and B equals 16. Lastly, C equals negative 1. Again, A equals 4, B equals 16, and C equals negative 1. Let's plug these into the AOS formula. So we have x equals negative b over 2a, which equals negative 16, because b equals 16, and 2 times 4, because a equals 4. 16 replaces the b value, and 4 up here, so the 4 replaces the a value. Next, we multiply in the denominator, so the top stays the same. What's 2 times 4? 8. So I have negative 16 divided by 8, which equals negative 2. Our axis of symmetry is x equals negative 2. Make sure to go through each step, and you can check your work by looking at a graph. Here's the parabola, and notice that our AOS is at x equals negative 2. We're correct. Please try this next example on Edpuzzle. Find the axis of symmetry of this function. F of x equals 2x squared plus 8x plus 7. Be sure to label A, B, and C first. In our next example, we have g of x equals negative 2x squared plus 4x plus 3. What are A, B, and C? A equals negative 2, B is positive 4, and C is positive 3. So A equals negative 2, B equals 4, and C equals 3. The formula for AOS is x equals negative b over 2a. So instead I'll have negative 4 over 2 times negative 2. So we replace b with 4 and we replace a with negative 2. Be careful with that negative. So let's see. Negative 4 stays the same over 2 times negative 2 is going to be negative 4. And negative 4 divided by negative 4 is positive 1. So our final answer is x equals 1. This is our axis of symmetry. Be very careful about using positive and negative integers. Our graph here looks like this. So the parabola with an axis of symmetry at x equals 1. Next we have g of x equals negative x squared plus 6x plus 3. What are a, b, and c? Pause the video and think about it. When you think you have an answer, press play again. So notice right here, this is where a would be. There's actually an invisible 1 right here, so a would equal negative 1, b equals positive 6, and c equals positive 3. So a equals negative 1, b equals 6, and c equals 3. Now let's find the axis of symmetry. So the formula we use is x equals negative b divided by 2a. What are b and a? So since b equals 6, I'm going to rewrite the numerator. I'll rewrite it here as negative 6. And a equals negative 1. So I have 2 times negative 1. Again, I replace the b with a 6. And I replace the a with a negative 1. We multiply for the next step. Negative 6 stays the same, divided by 2 times negative 1 would equal negative 2. And negative 6 divided by negative 2 is positive 3. So x equals 3 is our axis of symmetry. And a good way to check for work is by graphing the function and checking to see if our answer is correct. This is our parabola, and notice that the axis of symmetry is at x equals 3. That means we're correct. Try this one on your own. Find the axis of symmetry for g of x equals negative 3x squared plus 12x plus 2. Be careful about your positives and negatives. Next, we're going to find the axis of symmetry for h of x equals 2x squared minus 12x plus 20. What are a, b, and c here? A equals positive 2, b equals negative 12, and c equals positive 20. A equals 2, b equals negative 12, and c equals 20. Now let's find the axis of symmetry. Our formula is x equals negative b over 2a. So it'll be a negative, and then b is negative 12. Make sure you write both negatives, and then divide it by 2 times 2. So we replace the b with the negative 12, and we replace the a with this 2. Notice we have 2 negatives. This becomes a positive. So at the top, the numerator, we have positive 12 divided by 2 times 2, which is 4. And 12 divided by 4 is 3. So our axis of symmetry is x equals 3. The biggest point to notice here is that the double negative turned into positive. So negative 12 simply turned into positive 12. Here's the graph, and notice that the axis of symmetry is at x equals 3. Up next, I have h of x equals x squared minus 14x plus 8. Again, try to find a, b, and c on your own first, and then play the video to check your answer. A equals the invisible 1, and b equals negative 14. C equals positive 8. So I have a equals 1, b equals negative 14, and c equals 8. Let's find the AOS. I write the formula: x equals negative b over 2a. What do I replace b and a with? Well, I'll have negative, and then parentheses, negative 14. And then for the denominator, I'll have 2 times 1. This is because b equals negative 14 and a equals 1. A double negative would turn into a positive, so I have positive 14 divided by 2 times 1, which is 2. 14 divided by 2 is 7, so my axis of symmetry is x equals 7. Let's look at a graph. So here it's a little hard to see, but x equals 7 is the axis of symmetry, so we know we're correct. For the 9th example, find the axis of symmetry of h of x equals 10x squared minus 40x plus 10. Let's look at a few more examples. Here we have k of x equals negative 5x squared minus 10x. Let's identify a, b, and c. So a equals negative 5, b equals negative 10, and notice right here we have an empty constant. So c equals 0. A equals negative 5, b equals negative 10, and c equals 0. Let's find the axis of symmetry. The formula again is x equals negative b divided by 2a. So we're going to replace the b and the a. So for the top part, for the numerator, we're going to have negative parentheses negative 10. And for the denominator, we're going to have 2 times negative 5. It's because b equals negative 10, so right here, and a equals negative 5, right here. So we're replacing the letters with numbers. Okay, so since I see a double negative, I know that's going to be a positive 10. And 2 times negative 5 equals negative 10. 10 divided by negative 10 equals negative 1. Go ahead and pause if you would like to review the steps. I know I went a little quicker here. So we found the axis of symmetry. We know that the axis of symmetry is x equals negative 1. Go ahead and review each step to make sure it makes sense in your head. Try going over the problem on your own again. Here's the graph of this quadratic function. And notice that its axis of symmetry is at x equals negative 1. Please try this similar example on Edpuzzle. Find the axis of symmetry for k of x equals negative 2x squared minus 8x plus 4. Let's try one last example together. Notice here we have m of x equals x squared plus 9. Is there something missing here? Could there be a missing linear term? Well, let's see. So a is invisible, but it's still there. It's a equals 1. And notice that we're missing a linear term. So although we do not write it, there's technically a plus 0x right there. So b is 0 and c is 9. We have a equals 1, b equals 0, and c equals 9. Be very careful right here. B is not 9. Remember, b is associated with the linear term. In this case, it was an empty linear term. And we use 0 to signify emptiness. A is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is the constant. Okay, let's find the axis of symmetry. X equals negative b over 2a. In this case, that would be negative 0 over 2 times 1. This is because b equals 0 and because a equals 1. So negative 0 is the same thing as just writing 0. And we divide that by 2 times 1, which is just 2. But 0 divided by anything is always 0. So our axis of symmetry is x equals 0. So actually, whenever b equals 0, the axis of symmetry is simply x equals 0. Like you see here, the axis of symmetry is at x equals 0. It's actually right on the y-axis. So if b equals 0, then our axis of symmetry is x equals 0. Please try this final example on Edpuzzle. find the axis of symmetry for m of x equals 5x squared minus 3. What happens when b is 0? What is our axis of symmetry going to be? So as a quick review, the standard form of a quadratic function is f of x equals ax squared plus bx plus c. Today, we use this to find the axis of symmetry. The axis of symmetry splits the parabola in half so that each side is a mirror image. And we can find the axis of symmetry by using this formula. X equals negative b over 2a. Please remember to submit your notes on Canvas, and see you guys next time.